In this video, we're going to look at trial improvement. Now, trial improvement is a method for solving complicated equations when you can't maybe factorize or use your quadratic formula to solve the equation. So, for example, here we've got an equation which is x to the power 4 plus 2x cubed is equal to 3. Now, this would be very difficult for us to solve any other way other than using trial improvement. So, the idea basically is we try a number. So we put in a number, so say maybe x equals 2, and you see if x equals 2 works. So if you put in 2 to the power 4 plus 2 times 2 cubed, does it give you 3? And if it gives you 3, happy days, and your answer is 2. If not, then you have to try a bigger number or a smaller number, and that process continues until you get to within whatever degree of accuracy they're looking for. Okay, if you pause the video, you can have a look at all of this wee spiel. It just tells you the method for doing this, but we're going to jump to the questions and look at how we can actually do this now. Okay, so our first example says, solve the equation x squared plus x is equal to 83, giving your answer correct to one decimal place. It says use x equals 8 as your initial trial value. So what they have done here is they've put in x equals 8, and that means put in your calculator x 8 squared plus 8, and it gives you 72. Now our target value was 83, so it was too small. So you can write TS or TB for too big as well. So if that was too small, the logical thing for us to try would be to try 9. So on your calculator, you're just going to do 9, and it was 9 squared plus 9. And if you do that on your calculator, it gives you 90. So that's going to give you 90. I'm not going to bother filling this in. It's going to give you 90, which is just going to be too big. So the sensible thing then to try would be halfway between. So we can try 8.5. So on my calculator, I'm doing brackets 8.5, close my brackets, squared plus brackets 8.5. Now every time then I can go in and change that. And when I go in and do that, it gives me 80.75. So that's actually too small. Remember, my target is 83. So I'm going to try just 0.1 bigger. So I'm going to try 8.6. So 8.6 squared plus 8.6, and that gives me 82. So it gives me 82.56, which is still too small. Then I will try 8.7. So 8.7 squared plus 8.7, and that gives me 84. So 84.39 it was, so that was too big. Okay, right. Now what we have got, I've shown my answer lies between 8 and 9. It also now lies between, it's 8.6 and 8.7. Now we're to give our answer to one decimal place. So either one of these is going to be my answer, 8.6 or 8.7. Now at the minute, typically these are, you get 4 marks in the exam for this. At the minute, from all the working out I've done, I've got 2 marks. Now to get the other 2 marks, I need to do the next 2 things. So I need to first of all test, and I'm going to test halfway between these 2 values. So halfway between these 2 values would be 8.65. So if I test that, so on my calculator I'm doing 8.65 squared plus 8.65, and I do that on my calculator, and that gives me 83.4725. Doesn't really matter exactly what it is, but it does matter, it's slightly too big. Now because that is too big, if 8.65 is too big, then that means 8.7 would be way too big. So if 8.65 is too big, then you take your answer to one decimal place. Your ANS is 8.6 to 1 dp. Okay, and had your 8.65 been too small, that means 8.6 would have been way too small. Therefore, my answer would have been 8.7. Next question says, solve the equation 2x cubed is equal to x plus 1.8. I would rearrange this first of all, and I'd write that as 2x cubed minus x is equal to 1.8. So that gives me a target. So my x, I've got my x, and I've got my 2x cubed minus x, and then we're going to have our target. Then we're going to have our target value. And our target value this time is 1.8. And then we're going to say and I'm just going to call it comment this time. So comment is going to be either too big or too small. Okay, first thing I'm going to try is x equals 1, and when I put that in, again I'm going to leave this bit out, but you do 2 times brackets 1 cubed minus brackets 1, and that gave me an answer of 1. So it is TS, which stands for too small. I'll try 2 then, and you have to try 2, so you go into your thing and change your brackets. So it's 2 upon brackets 2 cubed minus brackets 2, press equals, and that gives me 14. Again, I've omitted this bit out, and this is too big. So my answer is somewhere in between the two of these. Now, it's going to be closer to the 1 than it is to the 2, because my target was 1.8, and 1 gave x equals 1 give me a value of 1, x equals 2 give me a value of 14, so way too big. So I'm going to go closer to the 1 than to 2 here to do this one. Okay, so I'm going to try actually 1.1, and when I did 1.1, it gave me 1.562, which was just slightly too small. I'll try 1.2, and when I try 1.2, it gives me 2.256, which is too big. Okay, what I know so far, I know my answer lies between 1 and 2. I also know my answer lies between 1.1 and 1.2. Now, we're to go to 2 decimal places here, so I need to go a wee bit further. Now, I'm going to guess it's slightly closer to 1.1 than it is to 1.2. So I'm going to have a wee go. And to be honest, before I would put any more onto my page, I would try a few out and see how close it's going to be. So I'm going to pause the video and do that just to see how close I can get without actually doing any working out here. Okay, so I'm going to do 1.13. 1.13, when I put it in, gave me 1.755795, which was just slightly too small. So I'm definitely going to try 1.14. So I'm going to go in and edit that, do 1.14. And happy days, it gives me 1.823088, which means it is slightly too big. So my answer is either one of these to 2 decimal places. But again, you must do your check or your test. So we'll test 1.135, the halfway mark of those. So go in and edit those to 1.135, and we're going to see what we get. 1.135, and that gives you 1.789 whatever. Which is just slightly too small. Now let's think about this. If 1.135 is too small, that means 1.13 would definitely be too small. So my answer has to be 1.14, and that's correct to 2 decimal places. This example says the length of a rectangle is 4 centimeters more than its width. Given that the width is x and the diagonal of the rectangle is 12, find the width of the rectangle. Okay, no idea, so let's do a wee diagram. Here we've got a rectangle. It has, the length of the rectangle is 4 centimeters more than its width, so if its width is x, its length is x plus 4. And we're also told the diagonal is 12. Now we can use Pythagoras then to set this up. So 12 squared is equal to x squared plus x plus 4 squared, and then we could tidy it up. That's going to be 144 then is equal to x squared. When you do out this bracket, it's going to be x squared plus 8x plus 16, and then that's going to be 144 is equal to 2x squared plus 8x plus 16, and then we'll just bring that across to the other side, the 16 I mean, and you're going to have 128 is equal to 2x squared plus 8x. Now this is the thing we're going to use to solve this using our trial and improvement. Now in actual fact you wouldn't do this, you're told to do it. Well, it's a trial improvement question, so we're meant to use trial improvement, but in actual fact if you're given this, normally what you would do is use just your quadratic formula or try factorizing to do it. But here, because it's trial improvement, we have to use trial improvement, so that's why we're doing it. And if you're asked to use trial improvement in an exam, of course that's what you're going to do. So here we'll just set this up. We're going to have x, our test value. We're going to have then what we get when we do 2x squared plus 8x, and then remember our target. Our target then is equal to 128, and then we'll do our comment. So what we actually are deciding. So we will run through this. We can get rid of all that. We can now ready to go. Okay, just pause the video again just to try a few numbers to figure out which whether I'm in the right ballpark. There's no point in just starting off and trying like x equals 1, x equals 2, x equals 3, x equals 4, and so on. Do a few out before you do anything else, and then get started before you put pen to paper. So I tried a few, and I found out that when I put in x equals 6, it gave me an answer fairly close to 128, so that's what I'm going to start with. So x equals 6, and just to show you the first one, I'm going to do 2 times 6 squared plus 8 times 6. That's what I put in my calculator, and that gave me 128, so which was slightly too small. So x equals 6 gave me that. I'm obviously going to try 7 then as my next one. And when you try 7, so 7, and again I'll just do this out, 2 times 7 squared plus 8 times 7, and that gives you 154, which is slightly too big. So my answer is somewhere between those. So I'm guessing it's slightly closer to the 6. Again, I'm going to pause the video and play around with it a wee bit and see. Okay, so I'm going to try 6.1. So 2 times the 6.1 squared plus 8 times the 6.1 gives me 123.22. So just ever so slightly too small. So I'm going to try 6.2. So we'll get and edit that to 2 times 6.2 squared plus 8 times 6.2. And that will give me 126.48. So still too small. And then 6.3 is going to do it for me. So 6.3, and again we edit those, change that to 6.3, and we just get there. So that was 129.78, which is too big. Okay, right, let's just check the question. Thankfully we only need to go to one decimal place. So what we've found so far, we know our answer lies between 6 and 7, and we also now know it lies between 6.2 and 6.3. So one of these will be my answer. So you must test. So we'll just say test 6.25. And if you test that out, 6.25, 2 times 6.25 squared plus 8 times 6.25, press equals, and you will get 128.125, which is ever so slightly too big. So your answer is x is equal to 6.2 to 1 decimal place. So let's just talk about why that is. If 6.25 is too big, then 6.3 would be way too big. That means your answer is to 1 decimal place is just 6.2, and that is it.